Hey, this is chapter 2.4, write equations of lines. So another form that our equation can take is point-slope form. So we can transform this from our simple y equals mx plus b form to y minus y sub 1 equals m times x minus x sub 1. And when we would use this is if we are given the slope and a point of an equation. And so we can plug that in with, so say we have m equals -3, and it passes through 5, 4. So we have our m, and we have our point. This is where it would be helpful to have point-slope form. If you think about it, it wouldn't be helpful to use y equals mx plus b form because, sure, you have the m, but you don't know how to plug in this. You could plug in this point as y and x, but your b would still be unknown. So let's plug this into our point-slope formula. So we have -3 as our m value and 5, 4 as our point. So again, our formula is y minus y sub 1 equals m times x minus x sub 1. And y we keep as a variable, and then we plug in y sub 1. So let's label this point x sub 1, y sub 1, so therefore 4 is our y sub 1. M we know is -3, we leave x, and we have 5 as x sub 1. Now if we simplify this, we get y minus 4 equals, and then we should distribute the -3, so -3x plus 15, because remember we multiply the -3 by x, and then -3 by -5 is 15, sorry. And then we can subtract 15 from both sides, or actually subtract 4, or add 4 from both sides, sorry. So adding 4 from both sides to get y by itself equals -3x plus 4 plus 19. And now we've transformed our equation from point-slope form to slope-intercept form. Now another instance in which we can use point-slope form is if we're given 2 points and we don't know the y-intercept or the slope, so obviously we can't use slope-intercept form. And if we're given 2 points, first we want to find the slope. So we can plug this into our slope formula. Remember that is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we can get our slope from that. And then we can plug it into our point-slope formula. So that m value actually will go here. And then x minus x sub 1. So we will choose one of these points. Say we have 5, -2, x sub 1, y sub 1. And then we just plug it in like we did in the last problem here. So we're going to practice writing an equation based on a word problem. So this is on page 100 of your textbook, and in the school year ending in 1993, 2 million females participated in U.S. high school sports. By 2003, the number had increased to 2.86 million. Write a linear equation that models female sports participation. So now that we've learned point-slope form, we'll be able to apply this to this word problem. And it was important that we learn that form because we will not be able to use slope-intercept form for this, as you can find out. So, well, first let's go through the problem. We know that first school year, so first, I'm just going to say first year even though it's 1993, we had 2 million. Second year, we had 2.86. Write a linear equation. So basically we can convert these to 2 points. So we have 1, 2, and then 2, 2.86. These are really our x values and these are our y values. So we can put them into points. And now, since we know the point-slope form, we can plug it into that form. So like last problem, we'll find the slope first from these 2 values. So let's label them x sub 1, y sub 1, x sub 2, y sub 2, and then plug them in. So 8 minus 2 over 2 minus 1 equals 6 over 1 equals 6 is our m. And then we will plug it into our y minus y sub 1 equals m times x sub 2 minus x sub, or just sorry, x minus, I will erase that, x minus x sub 1. So we have y minus, and we will choose one of the points, so let's just use this point here. Y minus 2 equals 6 times x minus 1. So for now, it doesn't specify what type of linear equation, it just says to write one, so I will leave it in point slope form. So our final answer is y minus 2 equals 6 times x minus 1. So there's a little variation on the next problems, and that is, so they're kind of the same as the other problems where we're given a m value and a point. Except this time, our m value takes the form of something that is parallel or perpendicular to an equation that we are already given. So let's just approach this problem as we would another problem that we just did. So write an equation of the line that passes through negative 2, 3 and is parallel and perpendicular to y equals negative 4x plus 1. So let's write down our point slope form. So y minus y sub 1 equals m times x minus x sub 1. And we want to write an equation that passes through this point. So let's plug the point in. Y minus 3 equals, we'll leave our slope blank for now, x minus negative 2. And our slope for the first part needs to be parallel to this equation. So we can see that our slope from this equation is negative 4. And parallel lines have the same slope, remember? So these are two parallel lines, they have the same slope. So therefore negative 4 is our slope. For our second equation, it needs to be perpendicular to y equals negative 4x plus 1. So let's just fill in our equation with what we already know. We'll use the same point. So y minus 3 equals, we'll leave our slope blank because it's going to be different, and then x minus negative 2. You can actually write this as x plus 2 if you want. It doesn't really matter. That would be more simplified actually. So we need to remember that perpendicular lines have slopes that are the negative reciprocals. So the negative reciprocal of negative 4 would be 1/4. So that is our slope.